What is a femtosecond? A femtosecond is 1,000,000 times shorter than a nanosecond. Yes, it's ultra-fast. Machining with long-pulse laser. The numerous physical phenomena that are present when machining with a long laser pulse. In many materials, it is not possible to create features with dimensions much smaller than 10 microns diameter. Heat diffusion affects a large zone around the machining spot. It is quite obvious that the machining process under these conditions is not very clean. The disadvantages of long pulse machining: contamination to the surrounding material, melt zone, recast layer, delamination, shockwave and micro cracks, damage to adjacent structure. Machining with ultra-fast laser pulses. Ultra-fast pulse energy is deposited in the material so fast that the material is forced into a state of matter that physicists call a plasma. This plasma then expands away from the material as a highly energetic gas, taking almost all the heat away with it. Very little heat is left behind to damage the material. This means that the machining quality is high. The advantages of ultra-fast laser machining: no splattering of material onto the surrounding surface, no melt phase, no droplets, high shot-to-shot repeatability, create submicron feature, machining accuracy. As the laser pulse enters, the free electrons can oscillate strongly, then occasionally collide with the bound electrons. The type of avalanche process depends on the presence or absence of a free electron in the beam path. This variable physical process leads to unstable machining rates. Ultra-fast pulses and their extremely intense electromagnetic fields. The avalanche ionization process can start immediately, reliably, and reproducibly. This leads to high-quality machining. Submicron features. Machining with ultra-fast laser pulses is a threshold process. Adjust the intensity of the laser spot on the surface of the material so that just the peak of the beam is above threshold. Then we will remove material only in that very limited area. That area can be as little as 1/10 the size of the spot itself. It is not possible to get comparable, highly repeatable submicron machining with long pulse laser systems. We do know that the very short optical pulses interact with matter in a manner that is totally different from traditional machining techniques. This makes for high-quality micro-machining results, shot after shot. Ultra-fast pulses can machine very hard materials with extremely high melting points, such as molybdenum, rhenium, and can machine features inside transparent materials. The working principle of the software is based on direct control of hardware, such as laser, sample positioning, beam scanning, power and polarization control, as well as shutters, interlocks, and peripherals. We can integrate the ultra-fast laser micro-machining workstation. Consists of customized software. Let us see some examples by ultra-fast laser machining. ITO film machining. This is one of the ITO film machining process. Here are ITO film examples and others by ultra-fast laser machining. Ultra-fast laser provide you highly reliable, reproducible, and submicron machining process. We believe it will be an important role in laser machining near future. Please contact us now for the next generation technology.